Welcome to the next video on HackerRank problems. And in this particular video, we're going to be sorting the counting sort 1 HackerRank problem. Generally speaking, in this problem, given a list of array of numbers, we need to sort that array out using the alternative sorting mechanism. But what is alternative sorting and what is comparison sorting? Let's get clarity around that first. So generally speaking, let me pull out my pen first. Generally speaking, a comparison sort, I'm just going to use C sort here, refer to that. Comparison sort is the most common type of sorting mechanism. And most sorting policies that you read, like buckets, insertion sort, like insertion sort, uh, you know, insertion short, there's insertion short, sort, bubble sort, so on and so forth. These sorting mechanisms are usually related to comparison sorts. Why? So basically, what happens in these sorting mechanisms, just as a quick refresher, I'm not going to go too deep into this because this is out of what we need to do. If we have an array of, let's say, 1, 3, 1, 7, and 2, let's say, right? So in a bubble sort, what would happen is that two adjacent numbers would be compared. One is less than 3, so no sorting occurs. Then 3 is compared to 1. 1 is smaller than 3. 1 is shifted to the right, and 3 is brought to the front. And then we have a value like 1, 1, 3, 7, and 2, right? Then comparison is done between 3 and 7, right? 7 is larger, so no action occurs. Then 7 and 2 are compared. 2 is less than 7, so 2 moves to the right. And then then we rewrite this figure here. So that is how comparison sorts work, right? Uh, uh, Rather, I think there's one more step to this sorting mechanism. So that's how insertion sorts work. They compare values next to each other and move based on which value is larger and shorter, right? So that's how basically comparison sorting algorithms work, right? So generally speaking, a comparison sort algorithm usually has uh, 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 has follows the time frame of n log n, because regardless of best case or worst case scenario, it goes over every element in the list to solve that problem, and that is how basically comparison sorting algorithms work. But that is not what we need to do today. In this video, we need to use the alternative sorting mechanism, but these are the most commonly used sorting mechanisms that are taught. So what is alternative sorting mechanisms, right? And that is something that we need to cover in this video. So A sort mechanisms are slightly different, right? So when we talk about A sort mechanisms, second, let me get that a little better. A sort mechanism, basically what happens there is we have an array of, let's say, 5 numbers, right? But regardless, what A sort does is we need to sort these numbers, right? So what A sort does is simply it creates an array of 100 numbers straight away, right? Corresponding to every digit in the number from 0 to 99. So that's an array with 100, size of 100, right? So this array has spaces, 100 indexes, right? And each index corresponds to the relevant value. So a 0 index corresponds to the zero value, how many zeros were in the index. 5, the 5th index position corresponds to the 6th value, so on and so forth, right? And the 99th position, reflects to the 99th, 100th position, so on and so forth, right? So that is basically how why this array is created. It corresponds to its indexes correspond to the specific position. And what we do in alternative sort is that every time a zero is encountered, we add 1 to the position where the zero index is being tracked. At one position, we add 1 we track how many ones in the list appears, and so on and so forth, right? And that is basically alternative sort. It goes over each of the value in the array that we have, and then of those 5 numbers, and within those 5 numbers, it finds basically how many ones are there, how many zeros are there, how many fives are there, and how many 99s are basically between 1 and 100. It calculates each and every value and how many times it occurs, basically. That's an alternative sorting sort is basically, right? With that out of the way, what do we need to do in this problem? If we look at at a foundational level in this particular problem, let me pull up and go over the text of this problem. So when we look at this problem, basically we need to do 3 things here, right? We need to count the occurrence of each number in a list and return it in an array of size 100 where each index contains the frequency, right? Uh, Again, like, let's go revisit this. We have 3 things that we need to do in this problem. Initialize the frequency array, basically create an array of 100 sizes from 0 to 99. Count the occurrences of each occurrence. After the loop, we return the frequency array back, basically. So that's what all we're doing. We're doing a simple process in which we are basically doing, running the A sort logic on an arrow. That's all we're doing in this particular problem. So we're going to work on that next, right? So to do that, let's go here. Let's remove this comment here and start coding this problem out. So to start coding this problem, first we need to initialize the frequency array of size 100, right? Which includes the zeros. So we say create that array with that particular size, right? So that's what we do. Then we count the occurrences of each number in the array. So to do that, we just do a for loop and just add whenever we encounter a specific number, we add 1 to that particular location for that number. So for num in array, add frec that particular position, we just add 1. After that, the next portion, we return the frequency array. That should pretty much solve this problem. And that's how we run an alternative sort algorithm. Let's check this logic out and see if this returns as intended. Yep, it sorts them as intended. And this is basically how you do an alternative sorting and solve the counting sort problem number 1 in HackerRank. That we're going to wrap this video up. If you got any value from this video, please like and subscribe, and please let us know in the comments any problem, any question that you want us to do. With that, we're going to wrap this video up and see you in our next video. Thank you.